Colloidal particles have charge. And what are the reasons for the charge? We discussed the three reasons, which are the capture of electron during the formation. That may be one of the reasons. And what is the other reason? Selective adsorption of ions from the electrolyte. That is another reason, isn't it? So here we can see adsorption of positive or negative ions. Preferential adsorption or selective adsorption of positive or negative ions. We can explain it with an example. Formation of silver iodide from silver nitrate and potassium iodide. When you mix silver nitrate and potassium iodide, what happens? Silver iodide will form as the product. And depending on the conditions, you will get a salt, silver iodide salt. And what will be the nature of the silver iodide salt? That we can see. We can prepare silver iodide by the addition of silver nitrate to potassium iodide, or by the addition of potassium iodide to silver nitrate. These are the two cases. By the addition of potassium iodide to silver nitrate, or by the addition of silver nitrate to potassium iodide. These are the two methods. When highly diluted solution of silver nitrate is added to highly diluted potassium iodide solution. So here silver nitrate is added to potassium iodide solution. The precipitated silver iodide absorbs iodide from the dispersion medium. You know, iodide is negatively charged. If it is absorbing negatively charged ion on the surface of the particle, surely it will be a negatively charged colloid. That is represented here. You can see AgI bar I minus. I minus is absorbed, therefore a negatively charged colloid. Now see the opposite case when potassium iodide solution is added to silver nitrate. Opposite case. When potassium iodide is added to silver nitrate, potassium iodide is added to silver nitrate, product is same. Silver iodide will form, but it preferentially absorbs Ag plus from the solution. So AgI bar Ag plus. Here what is absorbed? Positive ions are absorbed. So what is the charge on the colloid? That will be positive. So resulting solution will be a positive colloid. So it is preferential adsorption of positive or negative charge. Now we can see another case, formation of ferric hydroxide salt. Now ferric hydroxide salt is a positive salt. What is the reason? Ferric hydroxide salt is obtained by hydrolysis. Already we discussed the process of hydrolysis for the formation of ferric hydroxide salt. So in the process of hydrolysis, it will be positive. What is hydrolysis? FeCl3 is added to excess of hot water. Then hydrolysis will take place. FeOH thrice will form. That will adsorb Fe3 plus ions, preferentially adsorb Fe3 plus ion. That means the particles are surrounded by positive Fe3 plus, therefore colloids are positively charged. But if you are preparing ferric hydroxide salt by the addition of ferric chloride to sodium hydroxide solution, instead of Fe3 plus, OH minus will be adsorbed. OH minus. In such a situation, FeOH thrice will be negative. So these two examples are enough to understand the preferential adsorption of positive or negative ions by the colloidal particles or dispersed particles. As a result, what happens? The colloidal particles will get a particular charge. And due to this adsorption of positive or negative ion, double layer, charged layer formation is possible. We can consider the first case, formation of silver iodide by the addition of silver nitrate to potassium iodide. Consider the case, addition of silver nitrate to potassium iodide. When we add silver nitrate to potassium iodide, silver iodide will be precipitated and I minus will be absorbed on the particle, thus it will become a negative colloid. And therefore, here the outer layer is negatively charged. And this charge on the surface of a colloidal particle attracts counter ions from the medium. Here, which is the counter ion? K plus is the counter ion, because in the medium potassium iodide is present. So it will attract counter ions from the medium. So a layer of K plus will form very near to I minus. The combination of the two layers of opposite charges around the colloidal particle is called Hellman's electrical double layer. Hellman's electrical double layer. Formation of a layer that will be a combination of the two oppositely charged layers around the colloidal particle is called Hellman's electrical double layer. The first layer of ions, that is positive and negative ion, you can see it here. First layer of ions, positive and negative ions. The first layer of ions is firmly held and is termed a fixed layer. While the second layer, if there is negative ions, then there will be positive ion, then there will be positive ion, then negative ion. That way, there will be a group of ions around it. And therefore, we can consider a second layer of ions. And this second layer of ions is mobile, which is termed as diffused layer. So here you can see it is the diffused layer and it is the fixed layer. It is the fixed layer and it is the diffused layer. The potential difference between the fixed layer and the diffused layer of opposite charges is called the electrokinetic potential or zeta potential. So here develops a potential. Here develops a potential, and that potential is termed zeta potential. Or simply we can say the potential difference between the fixed layer and the diffused layer of opposite charges is called zeta potential or electrokinetic potential. And the next property, electrophoresis. Next property of colloids, electrophoresis. We know the colloidal particles are electrically charged. That means either positive or negative charge. So if we apply an electric field, surely the particles will move towards one of the electrode. If the particles are positively charged, that will move towards negative electrode, and if the particles are negatively charged, that will move towards positive plate. It is shown in the figure. It is a colloid. The particles are shown here. The particles are negatively charged. Isn't it? The particles are negative. So you can see the particles are moving towards the anode, the positive plate. And this movement of colloidal particles are known as electrophoresis. It is very simple, very easy to recollect and write. So just to see what is happening here. Colloidal particles are charged particles. So when you apply an electric field, the colloidal particles will move towards the electrode which is carrying the opposite charge. That process is known as electrophoresis. When electric potential is applied across two platinum electrodes, dipping in a colloidal solution, the colloidal particles move towards one or the other electrode. This movement is called electrophoresis. If you can prevent electrophoresis by some means, suppose you are not allowing the particles to move. If the colloidal particles remain stationary there, then what will happen? If the particles have positive charge, the dispersion medium has negative charge. If the particles are negative charge, the dispersion medium has positive charge. So if the colloidal particles are not moving, at the same time the dispersion medium, the molecules of dispersion medium begin to move. This phenomenon is termed as electroosmosis. Movement of dispersion medium in electric field is electroosmosis. What is the condition for that? The colloidal particles should be stationary. Then only electroosmosis will take place. Movement of colloidal particles in an electric field is known as electrophoresis. Electrophoresis. Now the next property, coagulation or precipitation. It has a lot of important applications. It is one of the important property of colloids, coagulation or precipitation. What is meant by coagulation? Precipitation, settling of colloidal particles. That is coagulation or precipitation. That means the colloid is changing to a suspension. Precipitation is the property of the suspension. Precipitates are suspension. So precipitation means a colloid is changing to a precipitate. That is precipitation or coagulation. The process of settling of colloidal particles, that is called coagulation or precipitation of the salt. The coagulation of the lyophobic salt can be carried out in the following 5 ways. By continuous electrophoresis. What is electrophoresis? The colloidal particles will move towards the electrode of opposite charge, and there it will gain electrons or lose electrons. And if there is neutralization of the charge, the particles can combine together and will be precipitated. So by continuous electrophoresis. Second, by mixing two oppositely charged salts. Take two oppositely charged salts, arsenium sulfide, negatively charged, ferric hydroxide, positively charged. Mix the two in equal amount. Then what happens? The charge on the colloidal particles will neutralize each other. Then aggregation of the particles possible. And when the size increases, it will settle down. That is the second method, by mixing oppositely charged salts. Third one, by boiling. Boil it continuously. During the boiling, what happens? Detachment of the adsorbed ions On heating, desorption will take place. So desorption of that sort ions will take place. As a result, the particles will combine together and will settle down. By persistent dialysis. Dialysis is the removal of excess electrolytes from the colloid. But a small percentage of ions necessary for the stability. And if you are removing all the electrolytes from the colloid, what happens? And there is no charge. The particles can combine together and will be precipitated. By addition of electrolyte, a small percentage of electrolyte is necessary for the stability of the colloid or for developing charge on the colloid. But if the concentration is high, a large quantity of electrolyte is present, then there is a chance for the neutralization of colloidal particles by the oppositely charged ion in the electrolyte. So it is the most common method of coagulation by the addition of electrolyte. Electrolytes are containing two ions, positive and negative, and the colloids will combine with the oppositely charged ions and neutralization will take place. Then particles will combine together and will be precipitated by the addition of electrolyte. That is the most common method. Based on this, a rule is developed that is known as Hardy-Schultz rule. What is the statement of Hardy-Schultz rule? The greater the valence of the flocculating ion is added, the greater is its power to cause precipitation. That means to arsenic sulfide salt, you are adding Na plus, Ca2 plus and Al3 plus, which is having higher coagulating power. Na plus, Ca2 plus or Al3 plus, you read the question. Read the statement. The greater the valence of the flocculating ion. Na plus, what is the valence? 1. Ca2 plus, what is the valence? 2. Al3 plus, what is the valence? 3. The greater the valence of the flocculating ion added, the greater is its power to cause precipitation. So which is having higher coagulating power? Al3 plus. For the last essay examination, there were a question. Arsenic sulfide salt is negatively charged salt. When you add calcium chloride solution to this, what happens? What is your answer? Precipitation. Instead of calcium chloride, if you are adding Al3 plus, then what will happen? What is the answer? Faster precipitation or coagulation. Because what is the reason? Al3 plus, the valence is more than that of Ca2 plus. Application of Hardy-Schultz rule. Did you understand it? Okay, Hardy-Schultz rule. Remember the statement and its application. In the coagulation of negative salt, the flocculating power is in the order Al3 plus greater than Ba2 plus greater than Na plus. Similarly, in the coagulation of positive salt, the flocculating power is in the order FeCN 6 times 4 negative greater than PO4 3 minus greater than SO4 2 negative greater than Cl minus. As the negative charge decreases, the coagulating power also decreases. Now, what is coagulating value? And what is the relationship between coagulating power and coagulating value? Coagulating value is defined as the minimum concentration of an electrolyte in millimoles per liter. Minimum concentration of an electrolyte in millimoles per liter required to cause precipitation of a salt in 2 hours is called coagulating value. Minimum quantity of an electrolyte in millimoles per liter required to precipitate a salt in 2 hours is called coagulating value. So if large quantity is needed, we can say its coagulating value will be more, but coagulating power will be less. So if large quantity is needed, coagulating value is high. As the value, coagulating value increases, what happens? Coagulating power decreases. So the smaller the quantity needed, the higher will be the coagulating power of an ion. Now, in the case of lyophilic salts, whether coagulation is possible. Coagulation is possible, but it is a little difficult. It can be coagulated by adding an electrolyte or by adding a suitable solvent. These are the two methods for the coagulation of lyophilic salts. No need to discuss the details. If you have such a question, is it possible to coagulate lyophilic salts? What should be your answer? Yes. What are the methods? By adding an electrolyte or by adding a suitable solvent. That is it. Now, protective colloid. What is meant by protective colloids? If you want to understand protective colloid, you should understand what is protection of colloid. Lyophilic salts are highly stable, you know, but lyophobic salts are not so stable. So for the stabilization of lyophobic salts, we can use lyophilic salts. When a lyophilic salt is added to the lyophobic salt, the lyophilic particles form a layer around lyophobic particles and thus protect the latter from electrolytes and coagulation. So that is protection. Protection of particles from electrolyte. How it is protecting the particles from electrolyte? By forming a layer around the particle. Lyophilic particles form a layer around lyophobic particles. So it will not allow ions from electrolytes to combine with the particles. Thus it protects lyophobic salts. Lyophilic colloids used for this purpose are called protective colloids. So lyophilic salts using for the protection of lyophobic salts are known as protective colloids. So it is enough for today.